Companies using serverless architectures often see huge cloud infrastructure cost savings. Some report savings of up to 60%, 70%, or more. Reinvesting those funds into innovation and growth instead of just keeping the lights on. It's a shift to renting only what you need when you need it. You only pay for what you use. Serverless eliminates the expense of idle resources. This is a strategic advantage, lowering the barrier to innovation, turning it into a growth engine, freeing engineers to build great products and deliver customer value. The savings are in dollars, focus, speed, and innovation. For DevOps teams, the daily reality is often a juggling act. They work to bridge the gap between development and operations, aiming for faster, more reliable software delivery. However, they are frequently bogged down by the complexities of managing infrastructure. This includes provisioning servers, configuring networks, applying security patches, and ensuring high availability. These tasks are critical, but they are also time-consuming and repetitive. They divert attention from the core mission of DevOps, automating pipelines, improving deployment frequency, and enhancing system reliability. Traditional infrastructure demands constant care and feeding, creating a significant operational burden that can slow the entire development lifecycle down to a crawl. This is where AWS serverless architecture enters the picture, not just as a new technology, but as a fundamental solution to these core challenges. Serverless is more than just no servers to manage. It represents a profound shift in responsibility. AWS takes on the heavy lifting of managing the underlying compute infrastructure. This means your DevOps teams are liberated from the endless cycle of server maintenance. There are no operating systems to patch, no virtual machines to scale, and no clusters to configure. This abstraction allows your team to elevate their focus from the mundane mechanics of infrastructure to the strategic goals of the business, like accelerating feature delivery and improving product quality. The relevance for DevOps is immediate and transformative. By building on a serverless foundation, teams can create highly automated, event-driven workflows with incredible efficiency. Imagine a world where a developer committing new code automatically triggers a build, a series of tests, and a deployment to a staging environment, all without a single server being manually configured. This is the promise of serverless. It enables a level of agility and automation that is difficult and expensive to achieve with traditional setups. This means faster feedback loops for developers, quicker time to market for new features, and a more resilient and self-healing system that requires less manual intervention from your operations staff. Ultimately, serverless empowers DevOps teams to fully realize their potential as enablers of business velocity. It aligns perfectly with the core principles of the DevOps movement: automation, collaboration, and rapid iteration. When your engineers can focus on writing application and business logic instead of wrestling with infrastructure configurations, their productivity skyrockets. This leads to a more innovative and responsive organization, one that can adapt quickly to changing customer needs and market dynamics. For business leaders, this means your investment in a DevOps culture pays greater dividends, translating directly into a stronger competitive edge and a healthier bottom line. The idea of a complete DevOps environment for just $100 per month might sound like a fantasy. We've been conditioned to believe that powerful infrastructure is inherently expensive, often leading to over-provisioning and waste. This project challenges that paradigm. I'm building a fully functional, scalable serverless architecture on AWS, with a strict budget of $100 a month. This is a practical demonstration of what's possible when you embrace the serverless model. Managing infrastructure costs can feel like a constant battle. Our architecture confronts these issues, aiming for cost predictability and operational simplicity. This is relevant for startups and small to medium-sized businesses needing lean budgets. The goal is to make powerful DevOps accessible to everyone. So, what exactly does a $100 a month DevOps powerhouse look like? It's not a stripped-down, compromised system. It is a complete, event-driven architecture designed for modern software development. At its core, we will build an automated CI/CD continuous integration and continuous deployment pipeline. This is the engine of any effective DevOps practice. Our pipeline will automatically spring into action the moment a developer pushes new code. It will manage the entire lifecycle, from compiling the source code and running automated unit tests to deploying the application to different environments, such as development, staging, and even production, all with minimal human intervention. To achieve this, we will rely on a carefully selected set of AWS serverless services that work together in perfect harmony. AWS Lambda will serve as the brains of our operation, executing code in response to specific events without requiring any server management. For example, a Lambda function could be triggered to start a build process. AWS Code Pipeline will orchestrate our entire workflow, defining the stages our code must pass through. We'll use AWS Code Build to handle the compilation and testing phases in a fully managed environment, and AWS Code Deploy to automate the final deployment. These services form a powerful, interconnected system that handles the heavy lifting for us. Our architecture will also include essential supporting components. We will use AWS API Gateway to create secure and scalable entry points for our services, allowing them to be triggered via simple API calls. For data storage, we'll turn to Amazon DynamoDB, a fully managed NoSQL database that offers seamless scaling and incredible performance without the overhead of traditional database administration. To manage our code itself, we can integrate with services like AWS Code Commit or even external repositories like GitHub. Every piece of this puzzle is chosen not just for its functionality, but for its alignment with the serverless pay-for-use model that keeps our costs incredibly low. The end result will be a lean, mean, deploying machine. This is an architecture that provides DevOps teams with the speed and agility they need to innovate rapidly. It offers a clear, predictable cost structure that business leaders can rely on. It's a system that scales automatically to meet demand, whether you're running one build a day or 100. Throughout this journey, we will explore not just the what, but the why behind each architectural decision, providing you with the knowledge to adapt this blueprint to your own unique needs. Let's get started and build a system that transforms how you think about DevOps infrastructure. In traditional infrastructure, whether on-premises or in the cloud, the concept of the server reigns supreme. DevOps teams spend time planning, provisioning, and maintaining these digital workhorses. A core challenge is capacity planning. The fear of under-provisioning leads to over-provisioning. These extra servers sit idle for the vast majority of their existence. This continuous drain of paying for idle resources is a fundamental inefficiency. This tyranny of the idle server creates a significant financial burden. The money spent could be directed towards more valuable activities. It's a classic case of resource misallocation. The DevOps challenge is balancing reliability with cost control. The goal is to pay only for the work being done, liberating the budget from idle infrastructure. Traditional DevOps infrastructure is a tangled web of servers, databases, load balancers, and security layers, each demanding constant attention. A single change can trigger unexpected issues elsewhere, making troubleshooting a daunting task. This complexity drains DevOps teams, forcing them to juggle countless technologies instead of focusing on innovation. The result? Slower development, increased risk, and fragile systems vulnerable to downtime and security lapses. The solution is to abstract away this complexity, letting platforms handle the heavy lifting so teams can deliver value, not just maintain machinery. By simplifying operations, organizations regain agility, reduce risk, and empower teams to build resilient, scalable systems. Cloud bills are notoriously unpredictable. One forgotten server or a sudden traffic spike can send costs soaring. This volatility makes budgeting a nightmare for CFOs, forcing restrictive policies that stifle innovation. The root problem? Billing is tied to abstract resources, not business value, making cost attribution nearly impossible. Serverless changes the game. You pay per event, per user, per image, per API call, directly linking spend to value. This transparency enables predictable, scalable financial planning that aligns with business growth. The future is paying for outcomes, not idle infrastructure. Cloud elasticity sounds great, but traditional scaling is slow, complex, and fraught with risk. Auto-scaling policies are tricky to tune, and scaling databases or apps often means downtime or overspending. DevOps teams get bogged down in reactive scaling work, turning growth into a source of anxiety. The goal is effortless, instant scaling, where the platform handles surges automatically, freeing teams to focus on features. For business leaders, this means growth is limited only by market demand, not technical bottlenecks. True elasticity lets you scale without the groans of legacy infrastructure. Manual maintenance, patching, credential rotation, endless alerts, drains engineers and kills morale. Highly skilled DevOps pros end up firefighting instead of innovating, leading to burnout and high turnover. On-call fatigue and constant interruptions make retention tough and productivity worse. The answer is automation. Eliminate toil, let systems self-heal, and free engineers for creative, high-impact work. For organizations, this means happier teams, better retention, and a culture of innovation. Invest in platforms that minimize manual effort. Your people are your most valuable asset. At the heart of serverless is AWS Lambda run code without managing servers. Lambda executes your functions in response to events, scaling instantly and charging only for actual compute time. It's the automation engine triggering builds, running tests, sending notifications, all without idle costs. Lambda's automatic scaling means no more worrying about overloaded servers or slow deployments. For business, this means faster innovation, lower costs, and a direct link between spend and value delivered. Lambda lets your team focus on what matters: building products, not managing infrastructure. If AWS Lambda is the brain of our serverless operation, then Amazon API Gateway is its public face, the secure and managed front door. API Gateway allows us to create, publish, maintain, monitor, and secure APIs at any scale. For our DevOps architecture, it acts as the primary entry point for triggering our automated workflows. By placing API Gateway in front of our Lambda functions, we offload a significant amount of boilerplate work, allowing our developers to focus purely on the business logic within the Lambda function itself, making our system more robust and secure by default. One of the key cost-saving benefits of API Gateway is how it integrates with the serverless pay-per-use model. For business leaders, API Gateway provides a layer of governance and control over the digital assets being created by your teams. API Gateway transforms your back-end logic into a managed, secure, and potentially valuable product that can be safely shared and scaled. Every application needs a place to store its state. For this, we use Amazon DynamoDB, a fully managed NoSQL database service that fits perfectly within the serverless paradigm. DynamoDB is designed for performance at any scale, offering single-digit millisecond latency. Most importantly, it eliminates the operational overhead of database administration. You simply create a table, define your access patterns, and start reading and writing data, allowing AWS to handle all the underlying complexity. DynamoDB serves as the persistent memory for our CI/CD pipeline. We can use it to store the status of each build, historical deployment logs, test results, and environment configuration parameters. The scaling and pricing model of DynamoDB is a key reason it's a cornerstone of our cost-effective design. With on-demand, you pay per read and write request, meaning you only pay for what you actually use. This pay-per-request model ensures that we are not paying for idle database capacity. While AWS Lambda is excellent for executing individual, short-lived tasks, real-world DevOps processes are often more complex. A CI/CD pipeline is not a single action but a series of sequential and parallel steps with conditional logic. You need to build the code, then run unit tests. If the tests pass, you might deploy to a staging environment and run integration tests simultaneously. If any step fails, you need to stop the process and send a notification. Managing this complex state and logic within individual Lambda functions can become messy and difficult to maintain. This is precisely the problem that AWS Step Functions is designed to solve, acting as the conductor for our serverless orchestra. AWS Step Functions is a serverless orchestration service that lets you coordinate multiple AWS services into a visual serverless workflow. You define your process as a state machine, a clear JSON-based diagram that outlines each step, the transitions between them, and the error-handling logic. For our DevOps pipeline, we can define a state machine that perfectly models our workflow. The first state could be a Lambda function that starts the build. The next state, contingent on the first one's success, could be a task that runs tests using AWS code build. Step Functions manages the state, handles retries, and executes the logic, ensuring the process runs reliably from start to finish. Using Step Functions provides immense benefits for the resilience and maintainability of our architecture. It makes complex workflows easy to understand and debug. Instead of digging through logs across multiple Lambda functions to trace a failed process, you can look at the visual execution history in the Step Functions console. It shows you exactly which step failed, what the input and output were, and why it failed. This dramatically reduces the time it takes to troubleshoot and fix issues. It also separates the workflow logic from the business logic, allowing your Lambda functions to be simple, single-purpose components, making them easier to test, reuse, and maintain independently. For business leaders, Step Functions translates complex, error-prone business processes into reliable, automated, and auditable workflows. This isn't just for DevOps. It can be used to orchestrate any multi-step process, from order processing to data analysis pipelines. By providing a clear visual representation of the process, it improves communication between technical and non-technical stakeholders. It ensures that critical business processes are executed consistently and correctly every time, with built-in error handling and retries that increase overall system resilience. This level of process automation and reliability is a key driver of operational excellence and efficiency in any modern organization. No cloud architecture is complete without a robust and scalable storage solution, and in the AWS ecosystem, Amazon Simple Storage Service, or S3, is really the undisputed foundation. S3 is an object storage service that offers industry-leading scalability, data availability, security, and performance. It's designed to store and retrieve any amount of data from anywhere. For our $100 per month DevOps architecture, S3 plays a multitude of critical roles. It's honestly far more than just a place to drop files. It's an active and essential component of our automated workflows, acting as the universal layer for storing artifacts, logs, and static content. In our CI/CD pipeline, S3 serves as the central repository for build artifacts. When our build process, managed by a service like AWS Code Build, successfully compiles our application, the resulting package is stored in an S3 bucket. This artifact is then used by the deployment stage to deploy the application to our various environments. S3 also becomes the destination for all our logs. Lambda functions, build processes, and application servers can all be configured to write their logs to a designated S3 bucket for long-term storage, analysis, and auditing. The cost-effectiveness of Amazon S3 is a key enabler of our sub-$100 budget. S3 storage costs are incredibly low, priced per gigabyte month. Plus, S3 offers different storage classes, letting us optimize costs even further. For example, frequently accessed build artifacts can be kept in the S3 standard class, while older logs can be automatically transitioned to cheaper archival tiers like S3 Glacier. This kind of intelligent tiering means we only pay premium prices for data that requires immediate access. The pay-per-request model aligns perfectly with our serverless philosophy. From a business standpoint, Amazon S3 provides an incredibly durable and secure foundation. With data durability of 11 nines, you can be confident that your critical artifacts and logs are protected. Its powerful security features help you meet compliance requirements. By using S3 as the backbone for data storage, you're building on a platform that can scale to exabytes of data without any degradation in performance. In a serverless architecture, security is paramount. AWS Identity and Access Management, or IAM, is the security backbone, enabling you to securely manage access to services and resources. IAM lets us grant specific permissions to our AWS services themselves, known as IAM roles. This principle of least privilege is fundamental to building a secure system. Tight scoping dramatically reduces the blast radius if a component were ever compromised. Implementing a strong IAM strategy is critical for our cost control strategy. This prevents shadow IT that can lead to surprise cloud bills and vulnerabilities, keeping our architecture lean and secure. For business leaders, a robust IAM implementation provides peace of mind and enforces corporate security policies. Now that we understand the key serverless services, it's time to assemble them into a coherent design. Let's lay out the blueprint for our $100 per month DevOps architecture. The goal is to create a fully automated continuous integration and continuous deployment pipeline. Our design prioritizes cost efficiency, automation, and scalability. At a high level, our architecture will be entirely event-driven. Every step of this process will be managed and executed by serverless components. The core of our design will be AWS Code Pipeline, which defines the structure of our workflow. For the actual work, we will use AWS Code Build for compiling our code and running tests. The deployment itself will be handled by AWS Code Deploy. Throughout this process, AWS Lambda functions will act as the versatile Swiss Army knife. This combination of specialized services and flexible functions gives us a complete and robust solution. It's a practical and repeatable pattern for building modern, efficient software delivery systems. Every DevOps pipeline begins with source code. AWS Code Commit provides a fully managed source control service that hosts private Git repositories. Alternatively, our pipeline can be triggered by external repositories like GitHub or Bitbucket, offering excellent flexibility. The magic begins with the trigger. we configure our pipeline to listen for changes on a specific branch. This event is the starting pistol for our entire CI/CD process. This trigger kicks off our master orchestrator, AWS code pipeline. Code pipeline receives this event and initiates the source stage. The source code is stored securely in an Amazon S3 bucket, ready to be passed to the next stage of the pipeline. This creates a clear audit trail, crucial for debugging, compliance, and maintaining a secure development lifecycle. Once our pipeline has the source code, the next step is to build it. We'll use AWS Code Build, a fully managed continuous integration service. Code Build eliminates the need to manage build servers, which is great for our budget. We define our build environment in a buildspec.yml file, included in our source code repository. This file specifies the runtime, dependencies, and build commands. Code Build spins up a clean compute container based on our buildspec.yml configuration, ensuring a consistent build. The output is stored back in our S3 bucket. You pay only for the minutes it takes to complete your build, aligning with our serverless goals. A CI/CD pipeline ensures confidence through robust automated testing, acting as a critical quality gate. After a successful build, a comprehensive test suite verifies new code and existing functionality. Catching bugs early is exponentially cheaper than fixing them in production. AWS Code Build runs unit tests by adding a testing phase to our buildspec.yml file. Failure stops the pipeline and notifies the team. Integration tests can be added as a separate test action in AWS Code Pipeline using Code Build or Lambda functions. This fast feedback loop allows developers to fix issues quickly, improving productivity and software quality. After our code is built and tested, it's ready for deployment. Simply overwriting the old application version is risky, potentially causing downtime. To mitigate this, we'll use a blue-green deployment strategy, managed by AWS Code Deploy. Code Deploy automates deployments to Amazon EC2, AWS Fargate, and AWS Lambda. The blue-green concept is simple. The blue environment runs the live traffic. For a new version, Code Deploy provisions a separate green environment and deploys the update there without affecting the blue environment. This ensures zero downtime. After deployment, tests validate the green environment. If tests pass, Code Deploy shifts traffic to green. If issues arise, traffic shifts back to blue. This minimizes risk and enables frequent, confident deployments, accelerating innovation and improving service reliability. A silent pipeline is a scary pipeline. For DevOps, visibility into every stage is key. They need to know when a build starts, fails, or a deployment succeeds. Our architecture must include state management and notifications. It's a core operational requirement. We need to track pipeline status and proactively alert the team, turning our system into a transparent partner. For state management, we'll use Amazon DynamoDB, a perfect serverless database for tracking CI/CD executions. For notifications, we'll integrate with team communication tools like Slack, using Amazon SNS as a central hub. This combination creates a powerful feedback loop. This fosters transparency and shared ownership, ensuring the system feels connected to the team. We've now designed all the individual components of our DevOps powerhouse: a source repository, a build engine, a testing framework, a deployment mechanism, and a notification system. The final and most crucial step in our design is to weave these disparate pieces into a single, seamless, and automated workflow. This is the master role played by AWS Code Pipeline. Code Pipeline is the orchestrator that defines the sequence of our stages, manages the flow of artifacts between them, and provides a single pane of glass to visualize the entire process from commit to deployment. It is the conductor that ensures every instrument in our serverless orchestra plays in perfect harmony. Our code pipeline will be defined with a series of stages that mirror our desired workflow. The first stage will be the source stage, configured to connect to our repository and trigger on new commits. The output of this stage automatically becomes the input for the next stage. The second stage will be our build stage, which invokes AWS Code Build, feeding it the source artifact. The third stage, test, could run integration tests or invoke a Lambda function for API validation. Each stage is a logical gate that must pass before the next one can begin. The deployment stages are where we see the full power of Code Pipeline's orchestration. We can define a deploy staging stage that deploys our application to a pre-production environment. Following this stage, we can insert a manual approval action. This causes the pipeline to pause and wait for a human to inspect the staging environment and click an approve button in the Code Pipeline console. This provides a crucial control point before deploying to production. Once approved, the final deploy prod stage kicks in, using code deploy to perform our safe blue-green deployment to the live environment, completing the workflow. This declarative pipeline as code approach is what makes our architecture so powerful, maintainable, and affordable. The entire workflow is defined in a template that can be version controlled and easily replicated. There are no servers to manage for the orchestration itself. Code Pipeline is a fully managed service, and you pay a small fee only for each active pipeline per month, with a generous free tier that often makes it free for small projects. This design provides an enterprise-grade CI/CD workflow with the operational simplicity and cost-effectiveness of a serverless model, proving that you don't need a huge budget or complex setup to achieve true DevOps agility. We have a solid architectural blueprint. Now, how do we build it? Instead of manually clicking through the AWS Management Console, we will build our entire system using infrastructure as code, or IAC. This practice involves defining and managing our cloud resources in human-readable text files. These files become the authoritative source of truth for our environment. We can store our IAC templates in a Git repository, track changes, and collaborate as a team. We run a command like samdeploy or cdk deploy, and the framework automatically interprets our templates. With IAC, we can tear down our entire environment and rebuild it from scratch in minutes. For business leaders, adopting infrastructure as code is a strategic decision that pays dividends in speed, reliability, and security. Staying under budget hinges on understanding serverless costs and how to optimize them. While cost-effective, serverless isn't free. Our compute cost driver is AWS Lambda, priced by invocations and execution duration. Every millisecond and megabyte counts. Optimization means making Lambda functions lean and fast, right-size memory allocation. Use tools like AWS Lambda Power Tuning to balance performance and cost. Minimize execution duration with efficient coding. Initialize clients outside the handler for reuse. Be mindful of deployment package dependencies to avoid long cold starts. Leverage the generous AWS free tier. Diligent memory and code optimization minimizes paid usage. This makes the $100 budget achievable for a functional DevOps system. In a fast-paced DevOps environment, security cannot be an afterthought or a final checkpoint. It must be integrated into every stage of the development lifecycle, a practice known as shifting left. Our serverless architecture is uniquely suited to this approach, allowing us to build security in from the very beginning. The first and most important layer of our automated security strategy is a rigorous application of the principle of least privilege using AWS Identity and Access Management, or IAM. As we define our resources in our infrastructure as code templates, we will also define the exact minimal permissions each resource needs to function. For every single Lambda function, we will create a dedicated IAM role. This role will have a policy attached that grants it only the specific permissions it requires. For example, the function that writes build artifacts to S3 will only have permission for the S3 put object action on our specific artifacts bucket, and nothing else. This granular control, defined as code and version controlled, is a powerful automated security guardrail. It prevents a potential vulnerability in one small part of our system from being exploited to affect other parts. Automated tools can even scan our IAC templates to detect overly permissive IAM policies before they are ever deployed, catching potential security risks early. Our next layer of automated security is integrating vulnerability scanning directly into our CI/CD pipeline. During the build stage, right after we install our application's dependencies, we can add a step that runs an automated scanner. Tools like SonarQube, Snike, or AWS Inspector can scan our source code for common security flaws and check our third-party libraries for known vulnerabilities. If a critical vulnerability is found, the scan fails. This, in turn, fails the build step, which automatically stops the pipeline. This prevents any code with known security issues from ever being deployed, effectively creating an automated security gate that every change must pass through. This shift-left approach to security is a game changer for both developers and the business. It provides developers with immediate feedback on the security of their code, allowing them to fix issues when they are easiest and cheapest to address. It moves security from being a bottleneck at the end of the process to being a shared responsibility and an automated part of the workflow. For business leaders, this means a significantly reduced risk profile. you can be confident that a baseline of security checks is being applied consistently to every single code change, helping to protect your organization's data and reputation in an increasingly hostile threat landscape. Building our system is one thing, ensuring it performs well under pressure is another. Performance tuning in a serverless world is different from traditional environments. We're not tuning operating systems or web server configurations. Instead, we're tuning the parameters of our serverless resources to match the specific needs of our workload. This involves a careful balancing act between concurrency limits, function timeouts, and memory allocations to ensure our system is both responsive and resilient. Getting these settings right is key to creating a system that feels fast and reliable to its users, whether those users are developers or automated processes. One of the most important performance settings for AWS Lambda is concurrency. Concurrency is the number of requests that your function is serving at any given time. By default, your account has a shared pool of concurrency, but you can also reserve a specific amount for a particular function. For a critical function in our pipeline, like one that processes deployment approvals, we might reserve a small amount of concurrency to ensure it can always run immediately, even if other functions are busy. This prevents a high-volume, low-priority task from consuming all available concurrency and blocking a more critical workflow, thereby improving the overall stability of the system. Function timeouts are another critical lever for performance and cost control. Every Lambda function has a configurable timeout, ranging from 1 second to a maximum of 15 minutes. It's crucial to set this timeout to a reasonable value, just slightly longer than the expected maximum execution time. Setting it too high means that a buggy function with an infinite loop could run for the full 15 minutes, racking up unnecessary costs. Setting it too low means the function might be terminated prematurely during legitimate processing spikes. A well-chosen timeout acts as a vital safety net, preventing runaway functions while giving legitimate invocations enough time to complete successfully. As we discussed in cost optimization, memory allocation is directly tied to CPU power and therefore performance. While our primary goal there was cost, here the focus is speed. For a compute-intensive task in our pipeline, such as zipping large artifacts or performing complex calculations, increasing the memory allocation can dramatically reduce the execution time. The key is to test and measure. By analyzing the execution logs and using tools like AWS X-Ray, we can pinpoint performance bottlenecks in our functions and experiment with different memory settings to find the optimal configuration that meets our performance requirements without breaking our budget, ensuring a snappy and efficient system. A system without deep visibility is a system you can't trust. To truly optimize our architecture, we need to go beyond basic monitoring and embrace observability. Observability is about asking questions about your system's behavior without predefining what to measure. It requires collecting logs, metrics, and traces. For logging, we'll leverage Amazon CloudWatch logs and implement structured logging. For tracing, we'll enable AWS X-Ray across our key services. X-Ray provides an end-to-end view of requests as they travel through our application. This gives us a service map that visualizes how our components are connected. Combining these elements gives us true observability. This allows us to understand not just that our system failed, but precisely why it failed. The ultimate measure of a DevOps pipeline success is not its technical elegance or its cost efficiency, but its impact on the developers who use it every day. A great pipeline should feel like a powerful assistant, not a frustrating obstacle. It should provide fast, clear, and actionable feedback that helps developers build and ship high-quality code with confidence. Therefore, a critical part of building and optimizing our system is focusing on the developer experience, or DevEx. We must deliberately design and refine the feedback loops that connect our automated system back to the human beings who depend on it. The most important feedback loop is speed. A developer who pushes code and has to wait 30 minutes to find out if their change broke, a unit test will quickly become frustrated and look for ways to bypass the system. We must relentlessly optimize our pipeline for speed. This means running stages in parallel whenever possible. For example, we can run our code linting unit tests and security scans all at the same time in parallel code build jobs. It also means optimizing each step, as we've discussed, by keeping Lambda functions lean and build environments minimal. Our goal should be to get feedback from the initial commit to the developer in under 5 minutes. The clarity of feedback is just as important as its speed. A cryptic error message from the pipeline is almost as bad as no message at all. Our automated notifications, which we designed earlier, play a crucial role here. When a build fails, the Slack message shouldn't just say failed. It should specify which stage failed, like unit test failure, identify the developer who committed the code, and most importantly, provide a direct, one-click link to the detailed logs for that specific execution. This makes the process of diagnosing the problem as frictionless as possible, allowing the developer to immediately jump in and fix the issue without wasting time hunting for information. Finally, we need to create a mechanism for developers to provide feedback on the pipeline itself. The pipeline is not a static entity. It is a product that should be continuously improved based on user feedback. We can establish a dedicated Slack channel for pipeline support, or use a simple ticketing system where developers can report issues or suggest improvements. By treating our internal development tools with the same care and attention as our external customer-facing products, we foster a positive engineering culture. This focus on developer experience leads to higher productivity, better morale, and ultimately, a more effective and innovative engineering organization. After exploring the core services and diving into the practical details, it's finally time to pull back the curtain and reveal our fully operational, serverless, DevOps architecture. What we've created is a cohesive, interconnected system, a lean, mean, deploying machine. The final setup is a sleek, event-driven CI/CD pipeline orchestrated by AWS Code Pipeline. The entire infrastructure is defined as code using the AWS Serverless Application Model, or SAM, making it version-controlled and easy to modify. Security is baked in from the ground up. The system is designed for observability, allowing us to understand its behavior deeply and troubleshoot issues rapidly. This final setup is a practical, replicable blueprint for achieving agility, reliability, and cost efficiency. Let's walk through a typical day using the system. Sarah starts by pulling the latest code and creates a new feature branch in Git. After coding, she commits and pushes her branch to AWS Code Commit, opening a pull request. Once approved, Sarah merges her code. AWS Code Pipeline detects the commit and starts a new execution. Sarah gets a Slack notification. Build started. Another notification. Deploying to staging. She views her feature live in staging and performs user acceptance testing. Satisfied, Sarah approves the deployment. The pipeline deploys to production using a blue-green strategy. Final notification, deployment to production succeeded. The entire process took less than 15 minutes. This allows her to stay focused and deliver value quickly. Achieving a sub-$100 monthly cost for a powerful system sounds ambitious, so let's break down where the money goes. Our serverless architecture means costs are variable, tied to development team activity. This pay-for-value model is the foundation of our cost efficiency, eliminating expenses of traditional infrastructure. Key services like Code Pipeline, Code Build, and Lambda have minimal costs due to free tiers and usage-based pricing. S3 stores artifacts, managed with lifecycle policies. Serverless deployments via Code Deploy incur no extra charge. API Gateway, DynamoDB, and SNS contribute minimally due to usage-based pricing. Adding it all up, a reasonably active team lands comfortably below $100. This makes powerful DevOps tooling financially accessible. Achieving our budget is great, but the true value extends far beyond cost savings. We've seen a dramatic increase in developer velocity and team productivity. By automating the CI/CD workflow, we've eliminated countless hours of manual toil, allowing developers to focus on solving business problems and writing high-quality code. This results in faster time to market and a more innovative engineering culture. System reliability and security have also improved. The operational simplicity of the serverless model is another key benefit. By offloading infrastructure management to AWS, we've reduced the operational burden, allowing our team to remain lean and efficient. Ultimately, these benefits strengthen the alignment between technology and business goals, providing agility and efficiency. Our serverless architecture's key promise is its ability to grow seamlessly as our needs evolve. The setup is designed with scalability baked into its DNA. Consider our DevOps team growing from 5 to 50 developers. In a traditional model, this would be a major crisis. In our serverless architecture, this growth is handled gracefully and automatically. When 50 developers merge code, AWS Code Build spins up 50 concurrent build environments on demand. There is no queue and no developer has to wait. AWS Lambda automatically scales to handle the increased load without manual intervention. The services scale from zero to massive volumes, absorbing the increased workload. The architecture grows with our success rather than hindering it. This provides peace of mind for business leaders. Our architecture can scale from a small zero state to a hero state, maintaining efficiency and cost-effectiveness. We embarked on a challenge, building a complete, powerful, and automated DevOps architecture. For just $100 per month, we leveraged AWS code pipeline, creating a seamless workflow from code commit, all the way to a safe, zero-downtime production deployment using AWS Code Deploy. We integrated automated testing and built-in transparent feedback loops. This empowers developers with a fast workflow, providing them with the confidence to innovate rapidly. It was a practical demonstration of a fundamental shift in cloud computing. We have proven that you do not need a massive budget to achieve DevOps excellence. This architecture is a blueprint that you can adapt for your own teams. It fuels business growth and innovation. The architecture we have built for under $100 a month is a powerful starting point. One of the most beautiful aspects of a serverless design is its inherent and almost limitless scalability. Today, this system can comfortably support a small team of developers with costs remaining minimal. Tomorrow, as your team or user base grows, this very same architecture can scale to meet the demand. This is a scalable cost model where you only pay for the growth you are actually experiencing. By constructing your own products using serverless services, you create applications that inherit the same incredible scaling properties. This allows your business to capture market opportunities without ever being constrained by the technical limitations. This is the true power of serverless. It provides a scalable horizon, empowering you to start small, dream big, and grow without limits. We have walked through every step of this challenge together, from the initial concept to the final, working architecture. We have demonstrated that a powerful, secure, and scalable DevOps engine is not only possible on a tight budget, but practical and accessible. Now, the journey continues with you. The world of serverless technology is constantly evolving, with new services, features, and best practices emerging all the time. The real power of this community comes from the sharing of knowledge and experience. Your insights, your challenges, and your successes are what help push the boundaries of what is possible with this incredible technology. Your voice is a critical part of this ongoing evolution. I genuinely want to hear from you. What are your thoughts on the architecture we built today? Do you see places where it could be improved or adapted for a different use case? Perhaps you have tackled a similar challenge and have your own cost-saving tips and tricks to share with the community. Leave a comment below and let's start a discussion. Share your experiences with serverless architectures, whether you are a seasoned expert or just beginning your cloud journey. Every question asked and every answer provided enriches our collective understanding and helps others who are navigating the same path. Let's make the comments section a valuable resource for everyone. If you found this deep dive into building a cost-effective serverless architecture valuable, make sure you are subscribed to the channel. We are just scratching the surface of what is possible with AWS. My next video is already in the works, and it will focus on advanced AWS tips for power users, diving into topics like complex IAM policy authoring, advanced Lambda performance optimization, and strategies for multi-region resilience. You won't want to miss it. Subscribing ensures that you get notified the moment it drops, so you can continue to level up your cloud skills and stay ahead of the curve in this fast-moving industry. Finally, I encourage you to take on the $100 challenge yourself. Take the blueprint we have discussed today and try to build it, adapt it, break it, and make it your own. The best way to learn is by doing, and there is no substitute for hands-on experience. The process will solidify your understanding and undoubtedly spark new ideas. Thank you for joining me on this incredible journey. I'm excited to see what you will build, and to continue the conversation with you as we explore the limitless potential of the cloud together. Now go build something amazing.